Hey, in this episode, we explore the fifth item in the recipe for carefree dependency management in Java projects. The first four items were about how to structure dependency management related and build related configuration in your project. The goal of these is to separate concerns when you use Gradle or Maven for both building your software and also doing your dependency management, and in particular to define the dependencies between your own modules and third-party modules. The first aspect, defining dependencies, is done in each of your modules independently. If you use one of the build tools for this, the build Gradle or POM.XML file should be exclusively used for dependency definition. All other build tool related configuration should move somewhere else. The also dependency management related aspect of defining version of third-party modules is one of this. Then you might need additional dependency rules as a kind of adapter layer to enrich the metadata of the third-party modules you are using. This is to enable the build tools to resolve all dependency conflicts to the result you desire. And then there's all the other build configuration that you require for the build tools to assemble, test, and deploy your software. This is unrelated to dependency management, and such build configuration usually does not need to be worked on a daily basis and can be handled, in contrast to the dependency definitions, by build experts in larger teams. Once this setup is established, it is desirable to have processes and tools that keep it structured and maintainable over time. This in particular concerns the parts that are worked on regularly. As mentioned, the first of this are the dependency definitions themselves, point 1 of the recipe. If a software consists of multiple modules, uses a fair amount of open source third-party modules, and is worked on by a team of several people, it becomes hard, sometimes nearly impossible, to keep the dependency definitions structured without additional tooling. For instance, here in our example, the code may be modified to not use any classes from Commons.io anymore. In this case, this direct dependency to Commons.io should also be removed, so that the dependency management tool can figure out if Commons.io is needed at all. However, these kind of adjustments can be easily missed if you need to do them manually. Ideally, the dependencies you define between modules are synchronized with what you actually use in your code. Luckily, there are dependency analysis plugins for both build tools that you can use. And you can make them part of a quality analysis pipeline, for example, a test or check pipeline you run on your CI system, so that inconsistent dependency definitions are discovered in the moment the code of the corresponding module is changed. Using such a plugin and configuring it as a permanent check is the fifth item of the recipe that we focus on today. Let's take a look at one of our modules when using Gradle without the Java module system. Our dependencies are defined in the build Gradle KTS files. The GemCatch stage module we are focusing on here at the moment has two dependencies defined. Classes from these dependencies are used in the codebase of this module. Therefore, the dependency definition is consistent with the source code. Now imagine we would have defined an additional dependency to Commons.io. If I have configured the dependency analysis plugin for Gradle and run the build, which in my case includes all the dependency checks, the check fails with an error, telling me to remove the Commons.io dependency from the corresponding module. If I switch to the module system-based setup, where I define the dependency in the module info.java file instead of the build Gradle file, the analysis will give the same feedback, only pointing me at the module info file to remove the dependency by removing the corresponding require statement. Detecting unused dependencies is only one of the cases the plugin detects. It also detects scopes that are inconsistent with how I use the corresponding module in my code, and it detects dependencies that are missing when I use a module that I can access through transitive dependencies, but to which I never declared a dependency on my own. I have a separate video talking only about the Gradle Dependency Analysis plugin, where I go into more detail what these cases are exactly. For Maven, there's also an analysis plugin. To look at this, I switch to the Maven setup of the example and then add the Commons.io dependency to the POM.XML file. And now, when I run the Maven build, where I've also integrated the check permanently, I will get a similar error that tells me to remove the Commons.io dependency from the corresponding module. Setting up these checks is not very involved. Both plugins come with a fair default configuration. In the case of Gradle, I configured the plugin in my quality check convention plugin, which is used in all of my modules through the Java module convention plugin. And then I configure it to fail on any issue it detects, as by default it'll only print warnings. And then I add the check tasks the plugin provides to the check lifecycle of my build, so that they run every time I run a check or build. If you have separate lifecycle tasks for checking, like a quality check task, which I used as an example in my video on Gradle's lifecycle tasks, you may also add the check to this one. The checks are quite fast and therefore can run regularly. Looking at the Maven setup, I have a separate parent POM for quality checks. The dependency analysis in Maven is a separate goal called Analyze as part of the Maven dependency plugin. By default, the execution of this goal is not bound to any of the Maven lifecycles, which means it won't run as part of the normal build. You can change that by defining a goal execution and bind that to the verify phase as shown here. Then there are a number of configuration options. For instance, you can make the build fail if any issue is detected. Talking about configuration options, both the Gradle plugin and the Maven plugin have a number of them. Therefore, if you encounter an issue that for some reason you can't fix, it's still not a reason to not use the plugin permanently. There are configuration options to exclude certain cases if you can't fix them right away for whatever reason. And therefore I strongly recommend using a dependency analysis plugin in your setup. When you have a well-structured dependency management setup in your project, configuring item 5 of the recipe should not be hard to do. Adding the dependency analysis is only a few lines of configuration code as we have just seen. If you don't have a well-structured setup yet, starting with item 5 is an opportunity to use the analysis tool to make sense of the setup you have at the moment and fixing things one by one. In that case, you can also switch the configuration to print warnings instead of directly failing the build, and then you can fix things step by step. So apart from having the analysis to keep a well-structured and maintainable structure over time, it's also a helpful tool to move an existing project setup to a more structured setup that follows the whole recipe. You can activate one of the analysis plugins independently of whether you follow other items from the recipe already or not. If you don't know where to start to improve your dependency management setup, I encourage you to do this as a first step. And once your setup is well structured, keep it as a regular check. A second aspect you should check regularly are the up-to-dateness of the versions of third-party modules. We will talk about that in the next episode. See you then.